All right, so for today's notes, basically we're looking at linear regression and correlation. So yesterday we talked about data plots, scatter plots, looking at residuals, and today we're going to continue looking at that. So the line of best fit is also known as the least square line. It's also known as the regression line, which is what I'm more familiar with calling it. So when you guys get to college, you're probably going to hear it said this way, the regression line. And it has three important properties. The first property is it is a line that minimizes the sum of squared residuals. Okay? And it is a unique line. It is unique to that data. Okay? Second of all, it contains the center of mass of the data. And that is the point of the mean x values, mean of the x values and mean of the y values, okay? So the center of mass is this statement right here is the mean of the x values and the mean of the y values, okay? And that's usually depicted like this, x bar, y bar. Okay? So that point is found on this line. Okay? Its slope and intercept can be computed directly from the coordinates of the given data points. Okay, to measure the strength of a linear relation between two variables, a correlation coefficient is used, and it is denoted by the letter R. What do you guys think R stands for? Residual. It's a good guess. Yep. Yeah, or regression. Yep, okay. You should use your statistics utility to calculate the value of R. However, you should be able to interpret the value of R in the context of your data. In general, the sign R indicates the direction of the relation, and its magnitude indicates the strength. Okay, so if you have an R of plus or minus 1, it's going to be a perfect line. Okay? If it's positive 1, that means it has a positive slope. If it's negative 1, it has a negative slope. If you have a correlation of R equals 0, that means there's no there's no correlation at all. There is no line. So for instance, this is an R equals 0, correct? Somewhere in between, this is the R6, but notice there's quite a bit of spread in there. A lot of places from between the points to the line. Okay? So this one has a 0.6 correlation. The first one is a 1, so it's really nicely in a line. Yeah?
So could you not draw a regression line for the other?
Yeah, there is no correlation. That means there is no linear relationship of it at all. Those are like random points. Okay? Yep, C is R equals 0 there. So same with these right here and below. This one's an R minus 1. So it's still a line, but it's going in a negative direction. Okay? This one, it's still got a linear pattern, but it's spread out a bit more from the line. And the last one has no linear correlation. It does have a correlation, though. What do you think it is? What? A parabola, right. So this one's probably more likely an x squared type of function instead of a line. Okay? So while the R says 0, it doesn't mean there's no relationship there. It just means it's not linear. Okay? So on the bottom here, you have like a little graph to help you figure out if it's like a correlation or not. Also, I like the pictures myself above better. Actually, it helps me. But if you look at this little graph, in the middle, none is it shows you that there's no correlation. And the further you get to -1, the stronger it is. And the further you get to +1, the stronger it is. Outside of 1, if you get something more than 1 or more than -1, or less than -1, I should say, that's impossible. Okay? So you shouldn't be getting anything like that. Okay, so what I've done, you guys, is actually taking the table from page 87. I've input it into the Inspire here, and we're going to actually run some statistics on it. What we're going to do is we're going to go to the menu, and see I have actions here. I can go to Data. I can generate sequences. That's not what I want, though. Let's look at statistics. I can find confidence intervals. I can find stat tests. So these are all things that I can do on the Inspire. One thing